All right, everyone, good evening. Welcome to yet another class for the DevOps, CodeCamp DevOps. Today we'll talk about containerization, yeah? So containerization is a very important crucial knowledge you need for your DevOps journey. It's very important that you learn the rubrics of containerization. You learn the rubrics of containerization because you most likely find yourself in situations where you have to package softwares to deploy them on any environment you probably want to deploy them to. So yeah, that's what we are going to learn tonight. We're going to learn tonight. So, okay. So what is containerization? Containerization is a method of packaging applications and their dependencies into a standardized unit for software development called a container. Yeah, so you definitely hear in your journey as a DevOps engineer, you definitely hear scenarios where they say, oh, package this application and deploy it on this environment. Package this application the and deploy it on the what's my channel? Because this guy on the Discord channel. Anyways, package it and deploy it on any environment, either it's AWS or Azure or any virtual machine. Yeah, so these containers are lightweight, portable, and allow for consistent environments. So let's say for example, yeah, let's use a lay example. You want to move a car from China to Nigeria, basically. You don't just drive the car because you can't even guarantee that the car will be suitable for any kind of terrain. For example, let's just say you want to be crazy enough to drive a car from China to Nigeria. You cannot, if it's a sedan, you definitely experience rocky roads, cold roads, deserts, and all those scenarios that you will encounter in that driving process, which will make the driving process longer and in turn will probably damage the car. You get that? That's if you're crazy enough to move your car. Yeah. But if you want to move a car from, let's say, China to Nigeria, you put it in a container. The container is put in a ship, and the ship is uniformly set. Now, the ship on the water is the uniformity. Any other thing on top of the ship, which are on the containers, are different setups. So you can put a car, you can put a lorry, you can put a tractor, all those things, but it is still in that same one ship that is still on the ocean, coming to Lagos or something. That is the whole concept behind containerization. You get, if I want to deploy a a PHP um, application, the PHP application, you may not know how to set up the server to accommodate that PHP application. You may probably have the knowledge to set up a server for a Python environment, but you'll be asked for a scenario where you have to set up the environment for a PHP application. That is where containerization comes in. What containerization does is that it encapsulates your PHP application so that no matter the environment that you put it in, it's going to run regardless because it is inside a capsule, which is the container. I don't know if you understand me. So if, for example, now I have a CentOS server, and inside that CentOS server, I still want to run my PHP application. Rather than trying to think of how configure this environment to run my PHP application, what I just need to do is to install Docker on the environment. And carry what they call an image and run it on the server, and it will automatically run the containerized application on it. So it enables your application to be portable. You get, you can move it across different environments. You can move it across a different environment, then line it, preventing the situation of now the main reason why stuff like Docker was created in the first place. Please confirm you can hear me.
Yes,
Hello.
yes, you can hear me.
All right. So the main reason why Docker was created in the first place was to solve the issue of it works on my machine. So previously, in the old days of tech, in the old days of tech, like I mentioned in the first class or the first few classes, when developers write code, you use flash drives or floppy disks to carry your code to another engineer to probably set up the environment to run the code. And all those mundane and manual processes, it's not really scalable, because if they don't set the right thing, if they don't set the right environment, the application will not run. And you hear things like, oh, this code worked on my machine, but it's not working on our second engineer's machine. And there will be a lot of back and forth, which will lead to very, very slow deployment time and cost. You get? So that's the whole concept. I've explained this whole concept of containerization, because if you're an environment, you'll be given software. Even as much as you didn't write the software, you'll be given software. You have to package it into what they call an image, and then that image is what will be deployed across, what will be deployed if you're if you're on a server, it will be deployed on the server. If you're working into containerized environment like Kubernetes and the rest, it's that image that will be deployed there. So yeah, let's move forward. I think I've moved faster than my shadow in that explanation. So most people confuse containerization with virtualization. They are they are they have underlying concepts, but they actually are they are different, but they are similar in their own way, basically. So your machine basically is like, when you talk of virtualization, so virtualization is like a house. You get, you have your full operating system. So that is basically what we do in what they call it in Vagrant is the whole concept of virtualization. Creating like an environment outside your normal operating system, and then that environment has its own full operating system, and within that operating system you can launch your apps, you can test stuff. So the whole concept of virtualization is that thing that we do with Vagrant, where we set up mini servers in our computer that has full operating system. So that setup now, it's like a house, like this image I'm showing here. It has a hypervisor, which is what is used to run the virtual environment. Then there are guest operating systems. So that's Vagrant's that Vagrant init that we do is like creating an operating system inside. They're creating an operating system inside the virtual machine, then using that operating system to run your app. So from the diagram, there's the infrastructure, which is your computer, your personal computer. Then there's the hypervisor. Hypervisor is basically what sets up that virtualization feature. Then inside the hypervisor, they have the guest OS. You see the guest OS, the guest OS, the guest OS, which is the different virtualized environments inside this whole infrastructure, Then you now have each app running on different guests. So if I want to run my PHP application on guest OS 1, I can run it on guest OS 1. I can run another application on another operating system. But this is that in the large scale, it takes up a lot of space. You cannot say, oh, you want to run multiple applications on different virtual machines. It's possible, but it is still expensive in the long run, you get. So and also another thing is that in that environment, it is slow to manage. Imagine you trying to manage multiple different applications across multiple virtual machines. It doesn't make any sense in terms of cost and scale. So that's why people have switched over to containers. Now, in containers, you have the infrastructure, you have your operating system, and inside the operating system, this operating system now can still be guest OS. You get, so operating system can still be guest OS. Now, inside this operating system, you have what they call a Docker container engine. So I won't use Docker because we'll talk about Docker, but there are many container engines. But inside this operating system, you have a container engine. Now, it's the container engine that now runs the multiple applications. So you can run it is more lightweight, it is more flexible, it does not occupy as much space as running a full-blown virtual machine will run, and it will still give you the best results that you need in terms of running that whole. So instead of you getting a whole virtual machine to just run one particular application, you can just spin up a Docker container to run that same application, and it will still give you the quality of efficiency that you need, in terms of scale and in terms of cost. That's the main difference between containerization and virtualization. Now, like I said, this is like a table. Now, containers and virtual machines. All right. So containers and virtual machines, you see, OS requirement. Each VM has its own OS. Each virtual machine has its own operating system. So, for example, now that time when we were doing when we set up Vagrant, you can see we use Ubuntu 22, and that little Vagrant setup had its own operating system inside. You get, but when you're running containers can share your host operating system. So even if you're using Windows, you can run a container and it will still run on your Windows operating system, and it will still execute whatever it wants to execute because it's lightweight and it's like miniature. This for size, the virtual machine is usually very large, but containers are usually small and lightweight. Startup time in minutes. So for you to start up a virtual machine, imagine if you need to troubleshoot a particular software in a particular virtual machine, you have to start up the virtual machine first, and then before going into wherever application is. But containers, you can just enter into the container and find whatever you're looking for inside, troubleshoot it and come out. As simple as that. As far as it's it's running. Then performance. Virtual machines are more resource intensive. So you know that when you're trying to use anything that concerns a virtual machine, you know that you're going to spend money on CPU because some softwares have high CPU utilizations. So you're going to spend, but this one is more lightweight. This one is more lightweight, so you won't really feel the impact of CPU utilization like that because everything you want to do is embedded within that container that you're putting it. Portability, less portable for virtual machines, highly portable for containers. Like I said, you cannot, for example, now your software is in a virtual machine. You cannot say you want to move that software to another virtual machine. Actually, if it's a situation where all your application, all your traffic is going to that virtual machine, it's going to crash. But if you're in a situation where you want to run a container on another host, you can easily just pull the image from the repository and run it on a different, as far as the image is updated. So that's what highly portable means. I'll go into all those terms in a bit. Key features of containers. Number one, isolation. Like I said, the containers in a the containers in the the containers generally are isolated. So each containers run independently. So you can have multiple containers on the same machine, and each of them will run on their own without having to interfere with each other, without having to still, oh, this one, like for example, now I have a container that is running a A application, B application, C application. The three different containers can run concurrently within the same machine perfectly. For example, now you have a front-end container. You have a full stack application. You built a full stack application. There's a front-end container. You can have a back-end container. You can have a monitoring container. You can have a database container, all within the same machine, and it will run perfectly without any stress. But by the time you want to spin front end, if you want to put front end on virtual machine, you put back end on virtual machine, you now put database on the same virtual machine, it will cause problem. That's why if you notice, when people want to now deploy applications on virtual machines, you now get to see situations where you now have to start using one virtual machine for front end, another one for back end, another one for database, then another one to monitor the application, which is insane. You're spending money, you're wasting time, and it doesn't make sense in the long run. So that is why containerization is important. Then it's lightweight. Unlike VMs, container shares the host kernel. That's what I just said now. You can run multiple containers on the same host operating system, and it will run perfectly. All you just need to do is identify where your container is, if you get anything that needs to be fixed. And you can fix it within the same environment. Portability can be deployed anywhere. So if you have a container, if you have an image, and probably you have a Docker setup on, let's say, a cloud provider or a server on-prem, or a server in your office or something, you can deploy it anywhere. And as far as the image is updated, you can always get your image. Then there's scalability. Scalability is also one feature. It is very, very difficult to scale. It is very, very, very difficult to scale virtual machines. Very difficult. But with a container, you can easily scale with tools like Kubernetes, Docker Compose, and all those ones. You can scale means adding more resources to make it, more reliable. That's what scale means in simple terms. So, is anybody having any question before I move forward? This class will be very, very introductory. We won't do any hands-on. I'll just show you a few things that have already been set up. Yeah, because like I said, it's an introductory class. So what we'll do is just introduction, talking about what images are, containers, and everything. So yeah, does anyone have any question before I proceed? If no one has. So why use containers? Number one, for consistency. Just like I said earlier, you want the same version of your application to be run across multiple environments. Unlike when you deploy on virtual machines, it's not as if you can't get that version of not as if you can't get that version the same version in a virtual machine, but just that with virtual machines, you get, with virtual machines, there's a way you will set it up. As your application grows, with newer versions and the rest, you constantly need to ensure that your virtual machine, your application meets the requirements of whatever you set up. And if you want to upgrade, it's usually quite difficult to upgrade such scenarios. I recently had a scenario where the virtual machine that they deployed the application on since 2019, this virtual machine was using Ubuntu 18 or Ubuntu 20. Now they are trying to do updates to the now they're trying to do updates to the they're trying to do updates to the application that they put on that virtual machine. The updates are refusing to run on the virtual machine because the virtual machine is outdated. So now I was now responsible to setting up a new virtual machine. I was like, let us containerize this thing, engineering scenarios. Like, no, let us keep on running what they're running. We have to set up a new virtual machine with the latest setups for them to run the new version of the application, which doesn't make sense on a long term. So in such scenarios, all you just need to do is to update the underlying runtime that is running on the container, and your application will run seamlessly. That's just it. That's what consistency means. Resource efficiency. There's no need for a full OS per application, which is most people, what they do is that, like I said before, you want to deploy front end, you want to deploy a front end application, you use one server. You want to deploy a backend, you use one another server. You want to now deploy what they call it, database, use another server. Sometimes when you now want to use the three of them same server, your CPU utilization will be reading maximum. That is what containers help us do. Resource efficiency. Faster deployment. Containers start almost immediately. So once they are deployed on whatever they are, it will kick off and it will pick up immediately. Microservice architecture. Now, it's a new concept in software. It's called microservice architecture, where different services can be knitted together to form one full application. You cannot do the same thing here. You cannot set up such systems where you're deploying on virtual machines. Most people prefer the microservice architecture because you can run multiple services at their individual components connected together. So if one component goes down, it does not affect the rest of the application. Modern applications do this. There can be an SMS service. There will be an SMS service. There will be a database service. There will be this one service front end, just like that. Different services running. So if per se the SMS service goes down, it does not affect the rest of the application. They just work on fixing that SMS service and it's back online. Unlike what they call monolithic, which is the opposite. Monolithic is usually these scenarios where you run on virtual machines. Once the software goes down, everything goes down basically. So containerization is very, very useful if you need to implement microservice architecture. Then security provides process isolation and reduce security risk. Now, Docker. Now, like I said, there are many other, not say many though, but there are a lot of container environments. There are a lot of them. There's Docker, there's Containerd, there's Podman, and the rest. But for the scope of this class, we're going to only talk of Docker. Remember when I told you about Ansible? We did the same thing in Ansible where I talked about Chef, Puppet, SaltStack, and Ansible and the rest. But for the purpose of that class, we didn't only Ansible. For the purpose of here, we are going into Docker. So Docker is the most widely used containerization platform that allows developers to build, manage, and deploy containers with ease. When you talk of containers, it's usually Docker. Most people, except in some external environments that they use stuff like all those other ones. You get. Then key Docker component, there is the Docker engine. That is the core component that you install on whatever you want to install on your on your operating system that runs these containers and man. So whenever you're you may be given a server to work in, the first thing you need to do is to install Docker on the server. So once you install Docker, Docker is like a package that you install. Once you install Docker, it's now responsible to create and run containers on the server. Now there's Docker images. So whenever you have an application, that process of packaging the application, is called creating an image of the application. So when they say, oh, create a Docker image of this backend application, it means that you should package the application into what they call into an image. So it is a read-only template that is used to create container. It's just like a file, basically. It's putting the application is like in like a file-like structure. Don't worry, I'll explain it to you when we do hands-on and when we look at these things. Then there's the Docker content. Now that file that you have created as an image, you get. That is what you now use to run what they call to create what they call Docker containers. So that container now is what will run on that machine. So that the process by which your image is running is what they call a container. So if I have a node, my client may give me a Node.js application or a JavaScript application. My first thing is to do is to turn the application into a Docker image. That's the first thing to do. Once I turn it into a Docker image, what they call you are building the image. So that process is what they call building the image. Once I've built it into an image, and now run it as a container. So it's that container now that will be running that people will have access to. So when they hit your website, www.xyz.com, they are getting access to a software that is inside a container. So if I want to change the server now, all I just need to do is to carry that image that I have built and put it to another server and run it, probably install Docker there and run it and to continue from there. You understand? Or if I want to update the image, for example, now I've added more components. That image now was version 1. I want to update the image to version 2. You update the image, there are a lot of versions. It's also, you can also version it, what they call semantic versioning. You can do, I'm sure most of you are used to, you see 1.0.0, that's what they call semantic versioning. So the last 0 is the last number is patch, the middle one is minor, and then the first one is major. So all those updates that you may just, very, very lightweight updates, that's what you put in the patch. So the image can be, for example, now you have your image is 1.0.0, and you just make a small change, let's say changing the color of the interface. You can put that change as 1.0.1. You get it will create a new version. So if you want to now deploy a latest version, I can just take the image version and then deploy it on another server, and it will still run perfectly. Then there's Docker Hub. Docker Hub is literally Docker Hub is a place where container registries or where images are stored. So once I create my image, if I want to store it, just like Docker Hub is just like GitHub, Docker Hub is just like GitHub, where you can store your image. There are also public images as well that you can pull, because there are thousands of software engineers that have built stuff over the years. So they store their software as images. So if I want to go and use, let's say now Peter has built something, and I want to reference that same build for my application, instead of me to build the thing from scratch, I can just go and pull an image that's, the image of the software and run it on my machine, and it will run to give me the same thing that Peter built previously. So that's the whole concept around containerization. Then there is Docker Compose. So Docker Compose is used to manage multiple services. So if you have multiple applications that you want to run at the same time, you use Docker Compose. So Docker Compose is a tool for defining and managing multi-container Docker applications. I have a front-end application. I have a back-end application. I have a back-end container. I have a front-end container, back-end container. I have a database container. I have a monitoring container. But I don't want to start running all these containers individually, one by one. I want to run them as a single unit, you get. So when they are up, when all of them are up, all of them are up. When all of them are down, when all of them are up, when one is down, it will show that one is down because probably you won't be able to access something. That's where you use Docker Compose. The most popular tool that people use a lot is Kubernetes. But Kubernetes is a bit more advanced. So we're not talking of Kubernetes here. Docker Compose is the best way to start. It's called orchestration. So you know how, the real meaning of orchestration is a choir. When that conductor is, waving his hands, and when he's waving his hands, multiple people are singing different parts of the song. That is what orchestration means in real life. But this is why it is named orchestration, because one setup now can control multiple Docker environments within your system. So that's what they call orchestration. This is what they call container orchestration. You get. So Docker Compose is an orchestration tool. It's a lightweight orchestration tool. It's not used in a lot of big setups, but it's the perfect way to start, because understanding Docker Compose will make you slide into the knowledge of Kubernetes. Yeah. So any questions so far? And this is an example Docker Compose setup. You have the version. The version is 3. Services. Then the service now has the web and the Redis. So you put your image and you put the pod that you want it to run, and then when you do Docker Compose up, everything will spin up at the same time. So this is the end of this explanation. So let me go over to a typical Docker file that you need to learn. So now, this particular application, I built it a few months ago. I built it a few months ago, and it consists of front end, back end, and monitoring. So the front end consists of front end is built on React.js. The monitoring is for typical Prometheus and Grafana, and that was out of the scope. And there's back end. The back end is built on Python. Now, you'll be asked to deploy this application. Oh, your developers have worked on it. It's your turn to deploy it. DevOps engineer. First thing you need to do, write a Docker file for each component. Now, this is a Docker file for this. Now, this is also the Docker file for this. First of all, like I said, that's why in hindsight, when we go back to the first class we had, what did I ask you? When someone asked me, is it good to know how to code? What did I say? I said yes and no. You don't need to, you get, but it's beneficial if you understand some certain component because you will use it. Because you may be asked to Dockerize a React application. You have to know what component, what part of how the application runs manually first before you have to package it, because it is how it runs manually that will enable you to package it properly, that will run on the container. So that's why you have to have that underlying understanding. You get. That's why when somebody asks that question, I said yes and no. You don't necessarily need to write mission critical code, but that underlying understanding of this application, you have to understand it. Now let's look at this Docker file together here. First things first, you have from node LTS. Now imagine this is a blank board that we need to deploy our application on. You get. first things first, from Node LTS. This is Node LTS. Now, LTS is like the latest long-term support version of a particular software. You can put the version like 20 or 22 or this thing, depending on the version. But your version must rhyme what is on the package or JSON. Now, this package or JSON is your version must rhyme what is used to build the application. So, like I said, that's why you have to interact with developers. Oh, which Node version did you use to build this application? If they say, oh, they use Node 20, you now use Node 20. So this from now, you are setting your environment, your image to, it's like when you're frying food, you know that part where you oil in the frying pan. I'm trying to explain this thing to you in the most basic way. So that's why it need to pepper my body when people say you don't understand. You know, when you oil the frying pan, basically, so you are telling your container, okay, the first step, the first step is Node. So this is a Node application. So you are pulling a Node image first. So it's a Node image that will be the first in the template. That is what so that your container now, it is creating a Node environment, in an environment that will accommodate your Node application. That's what this from means. So you are pulling it. So that image now, this from now automatically sets your containerized environment for Node. You can put 20. Sorry about that. You can put 20, you can put depending on the version, but I just put LTS here because if the application keeps, if new Node versions still come up, it will automatically always just use the latest Node version. That's why I put LTS. But most people don't put LTS, especially in a production environment. You have to specify the version. Now, work dir, work directory. It is setting the directory inside the container at /app. You understand? It is setting the directory inside the container to /app. So that /app, it's where it will go and store your software in the container. You can leave it empty, you can just leave it as dots. So it will store it, but people use /app just to create that compartmentalization. You know, that part where it will be like /app to create that part. So whenever you are entering into the container to view anything, you know that your software here is /app. You get. Now, like I said, this is very, very peculiar to JavaScript environment. You can be asked to deploy anything. That's why I chose this particular project I've done, because it contains JavaScript and it contains Python. You get. Now, in a JavaScript environment, there's what they call package.json. Package.json is where all the dependencies that this software runs on are kept. You get. That's what package.json is. It's by default. Once you want to run JavaScript setting. Hold on, I'm coming. So yeah, I'm back. So by default, so now you have to ensure that you copy the package.json. The reason why I put this star here is to encompass anything outside. It's like they call it wildcard. So it encompasses anything outside, anything after package. So this one now you are seeing package log, because you may build an application where there are multiple package.json files. It can be package dev, it can be package log, kini. You just put this one. So when it will take both package.json, which is this, and then to take anything that has anything outside package. This is what we call wildcard. It's a wildcard sign. So this one that has dash lock now is going to also put it because it is still the same. That's what package, that's what this sign is. So copy these two into the container, which is this app. So since you have set your working directory to app, it will copy this package.json inside that app directory. Then you now do run npm install. So inside the container, you're also doing run npm install. npm install is basically installing those dependencies in that container. So all these dependencies that are here that will help you to run the application. If you look at this package.json, I just open now, all these dependencies that are here that will help you run the application, that helps you to run your application, it's going to install them in the container. It's going to install them in the container. You understand? It's going to install them there. So then copy dot means that copy from current working directory, which is this environment, to the app directory in the containerized environment. So you're copying all these other things here: public, source, kini, Vites, all this, so you're copying every other thing inside. So we have already installed all the dependencies. You're not copying the rest of the code inside. You get now. Another thing is to expose this port. So this port now is what we use to run the application. So this port now is what is used to run the application. So you're telling to tell you that you should expose this port. I think it's here. Let me check if they wrote that thing here. Well, it's not even my code. But anyways, this is 5173. This is the port to use. Now, once I expose it, you now do npm run dev. So this npm run dev is the command that is used to run the application. So now, once I've written all this code, if you are not an expert, it will, when you are running it, it will fail. When you're running it, it will fail. When you're running it, it will fail. Then there's what they call, you now use a build command. So there's what they call docker build dot. So once you have written this setup now on your Docker environment, you now build it. So you use the command docker build dot. That's build what is currently, or build the Docker file that is currently in this environment. When we're doing hands-on on Friday, we'll go through everything from scratch. Then, like I said, it will build it into what they call an image. It will build it into what they call an image. Now that image now is what you hold in your hand. Is what it's like a file. It's not a tangible file, not something I can touch, but it's like a file on your machine. You now deploy it into where they call Docker Hub. This is hub.docker. Search Docker Hub. So yeah, this is Docker Hub. So you now deploy it here. So there are a lot of images. This is TensorFlow image. If I want to build an application and I need to run TensorFlow in my application, rather than using it from scratch, I'll just come here and pull this image. You can see 50,000 pulls. This one, PyTorch. There is memcached. So if I want to build an application now that I need memcached to run cache services on the application, I can just come here and pull memcached and then run it and then see 1 billion pools. Nginx. Then there's Alpine. Alpine is a minimal Docker image. So there are a lot. Postgres. So for situations where, you need to run like tests, what they call it? Test databases, but you don't want to Well, start renting database. You can just pull a Postgres database and use it on your application. It's also good for, I don't know, I've not used it in production before, but it's good for testing. There are a lot of them. So when you create an account here, I have an account once. I'm using a different computer. So there's MongoDB, there's Grafana, there's no software that does not have an image. Popular software does not have an image. So that's why building is easy, because you can just easily pull here, pull here, pull here, combine, and then run the application. You get. So that's what aids what they call the microservice approach, because the only thing you're responsible for is your code. You can, if you want to implement, for example, in your code that you want to implement cache services, you can just come here, pull memcached or pull redis, and you run it on your application, basically. So yeah, this is so once you have built the image, you can now push it to your own repository. Mm, sorry, I'll log in. You can now push it into your own repository. Then you can now do anything you want with it, so that you can store your own image there. All right. All right, so this is my own repo. This is my own personal repo. Yeah, yeah. What's going on? Okay. So this is my own personal repo. Yeah. And yeah, these are the images that I've built so far. When you build it, you push it. And then when you push it, it will come here and stay. So your any image you want, like now, for example, now anybody in this class can go and pull this web app and run it into on the application. The only downside is that it's connected to other software. So because it's a public, like I explained for Git, it's also this is a public repo. So anybody can come here and pull it and use. You get. So yeah, basically, so that's just how this is the environment for the Docker Compose, for I say Docker Compose, Docker Hub. Now, this is also Python as this is like a Python environment. This is the Docker file. Now, first things first, when they give you a you start, create what they call a Docker file. Docker file with capital D, Dockerfile. Docker file. Docker file now that we want to encapsulate. Now, you have a Python Docker file. This is not just specific, this is not generic for Python. This is for Fast API. Fast API is a framework for Fast API is a framework for Python. Fast API is a framework for Python. So, like I said, you also have to know how do they deploy Fast API applications. You also have to know. I have been given a task where I deploy Ruby on Rails. Ruby on Rails. Like I've never ever written Ruby on Rails code in my life. But you have to do research. You have to find out. You have to push basically. Now this is from the same way too from the Python version used to build application is Python 3.10. You get. So you have to set it from 3.10. This is the parent image that to be used. Then this set is used to run script. If you want to run a script within the setup, you use run. So this particular setup means that if any part of this, this whole build fails, the whole setup should fail. That's what this means. Then install poetry. So inside that your container, you're going to install package called poetry. Poetry is like a package manager. It's like a package manager for fast API application. You get you install poetry. So you use the command to install poetry on that container. It's like working on a server, but this one is more lightweight. You use this package to install poetry on that setup. Then you set the path, your path. Then you run poetry. This one is not even compulsory. It's just for checking and testing. Like I said, you now set work directory app. So you set the work directory to app. So this is you must be sure. Most people now ask if you set work directory on if you set the work directory on poetry. If you set the work directory on front end as app, why do you not have to set? Because they are different containers. This one are going to run totally different containers. So you can still set your work directory as app in this one as well, because it's a different container that will be running all together. You understand me? Now, there is copy what is here into app. You can still put unlike that one that you have to copy package management. This one you don't need to copy package management. There are different approaches though. But this is my approach. You copy everything inside here into app. This one also has this poetry.log. This PyProjects.tme it's also the dependency as well. So these are the dependencies that are used to run the application. So you can also choose, you can also choose to do copy PyProject .toml dot and then run poetry install inside to install those dependencies before you copy everything. There are different ways to kill a fly, but I'm just showing you the approach. Then you expose 8,000. So 8,000 is the what they call it. 8,000 is the port that is used to run the application. So once you expose it, it's exposed to you can piping the application through that particular port. Then it now tell you start. So this command to start the application. If you're running on a normal machine, this is the command you use to start it. So it's already telling you to, you're putting the command that when all these things are said and done, you should start the application using this command. You have to know all the commands basically. You understand? So after you have run this now, you also build this into an image. You build this into an image and then push to Docker Hub. That you have your front end and your back end image set. Now, once you have set this up, if you want to deploy, you go to the server where you want to deploy this application. Go to the server where you want to deploy this application, you install Docker. You now pull these images. You pull these images, and then once you pull them, you run them on the server, and both of them will run. The back end will run on the server, the front end will run on the server. Now, what you now need to do is most people do is, since there are some components of the back end and the front end, they will use the IP address of the server that they are running it on, connect to the front end. So once it's set up, basically, the front end and the back end, don't worry, all these things you will see when we do our hands-on Friday. So yeah, basically. So that's how the whole containerization works. You build the image, you push it to Docker Hub. First of all, log into Docker Hub and then you push it. And yeah, that's the whole concept, basically. So is there any question so far? So now everybody's quiet.
Okay, sir. Good evening, sir.
Yeah.
Okay. For clarity, this Docker file, Are we the ones to write it, or it will automatically display like this, and
No,
then you'll be
you are the one that will write it for every project. Like I said in the class. Well, you'll be given a raw front end and back end code to work on. That's if you are not a DevOps engineer, if you're the single DevOps engineer, but sometimes if you know the code, if you know like if you know like the programming language, you build everything from scratch and then you write Docker, you write it. Once you're given a file, the first thing you do is to write. That's even you're going to be the next steps. Because I'm going to just give a front end and a back end of an application. And I'll tell you who to write it. Build the whole thing from scratch. And you will show me the IP address. You will do don't worry. I'm not going to expose it for you to see. I'll just give you a front end and back end of an application. And you're going to write it. You write the Docker file. You're going to show me evidence of the Docker container the Docker hub account that you have pushed it. And you're going to show me where you have deployed it to. You can easily just deploy it, or you can even deploy it on your laptop using localhost. But I want a situation where if you type localhost on your laptop, it's the front end that will show connected to the back end, basically. So that will be the next task. But I'll have to explain on Friday. I'll do like a proper hands-on Friday, so everybody will see how it works. Don't that Jibola is giving me shock emoji. No problem now. Don't submit. So yeah, basically. So I'll give you only the front end and the back end as a scenario where you're the DevOps engineer and deploy this application. Make sure it runs on your local host. For those that don't have local host, you can go and get a server and then make sure it runs there. So when somebody clicks the IP address of the server, it's your application that will come up. We'll see. So yeah, any more question?
Good evening, sir.
Good evening. I can't hear you. Your voice is really low.
Okay, can you hear me now?
I can hear you.
Yes. I'll try work on, though my question is not on this class. My question is based on last class, AWS.
I have not taught AWS, so
As in me, I worked on it, on the Ansible you talk about. So I just tried to do some simple, I laid my hands on simple projects. So I did this. So I now try to create an account with AWS. But the issue I'm having is the account is not accepting my card. So and I've tried
AWS does
all
not
what
work
I
on your
could.
account. You have to open a gray account for a virtual USD card. Or you can go and get a USD card or in a bank.
I
But it's
use
best
I
to
use
just
a
use
Mastercard.
internet. It does not work with Naira accounts.
Okay.
I use Gray. I use Gray for my AWS and I use GigPay for my Azure.
Oh,
That's what it is.
wow.
Well, good job so far on your practice.
So, okay, sir.
So yeah, is there any other question? So that's just what it is, basically. That's just what it is. So in hindsight, like I said, Docker images are built from, you build your software into a Docker image. And once you have, now this is a Docker image for Python. This one is for Python because this backend was built with Fast API. This front end is built on React. Yes. Now look at a typical example of Docker Compose. This is more this is this is how will I put it? It's a bit disorganized, but I'll explain. Now, leave this include. This includes is trying to import this other Docker Compose. So I'm not going to pay attention to it. But this is when you want to write a Docker Compose file, you get. I'm giving you Expo now when you want to do your own setup. When you want to write a Docker Compose file, first thing you will do is services. You get Services is the service that is going to run. So all these things now are services. They are called services. Front-end service, back-end service, database service, monitoring service, engineering service, traffic service, memcached service. They're all called services. You get. Now, the first thing we're going to do is the back-end. Now, if you notice that there's a bit of an indentation here, please don't come and meet me on Discord and say, your kini failed because of we tried this. It's in YAML. We're using YAML for this. YAML is very, very strict on indentation. If I were you, I'll go and watch a few videos on YAML to understand it. I'm not going to teach YAML. Something that you can watch like a 30 minutes video and get the concept. Under services, you see backend. Now, under this backend, now you see a build. This build now is telling you that first things first, you have to build the Docker file if it's not present. Now, if in a scenario where you don't want to push the Docker file to Docker Hub, you want to run everything locally, you build it. The only downside is that for every time you have to keep on building. But it is still good because you still keep your software and its images within the local machine. There are still some that you can, once you push, this context now is pulling from Docker Hub, but that's different. Now, this is backend. It's going to pull from here. See this ./backend is here. This ./backend now. Here is Docker file. It's going to pick Docker file from here. If there's no Docker file inside this ./backend, it's going to cancel. It's going to give error in this point. So container name fast API app, just a regular container name. Then there's port 8000. The port that is running the application is 8000. Then it depends on now is also very important because if you're running an application now that needs a database, if you're running an application now that needs a database, it will not make sense for your back-end application to run before your database runs, because your back-end application will depend on the data on the database. So you have to depend on, that means in this scenario, the database service will have to run first before the back-end runs. Now the env file is inside here. So this is the environmental variable that will use to run the application. Then network. So just like what I explained, all the services are connected to the same network. You understand? There's what they call a Docker network. So the Docker network is what houses individual services. They make them communicate with each other. If there are multiple networks in the Docker environment, you have to choose one that will interconnect all your applications. You understand? So I've already created a network here called shared network. That's the name here, which uses a bridge. So the bridge network basically creates a connection between all the services combined that will right inside here. Now in this setup, this network, shared network, front end the same thing. Context, front end, container name, Node.js app, port. This is the port now open. So this is the port that is going to run the software to. env file. The env file is there, is what is inside here. Then network, shared network, have the same network. I even made a mistake here, so I could have put depends on I think I did it in the next version. This is the first version I built. Depends on backend. So when you're doing, if I'm assigning these tasks to you, that's what you need to do. Your application must depend on backend. Backend must depend on database. Network, shared network. Shared network. Now, DB, which is the database. This is the name. It's going to pull Postgres latest. Now, that Docker Hub that I showed you, remember when I showed you Docker Hub? It's going to go there and pull. Now, you don't need to, the reason why The reason why you don't need to explicitly specify, you don't need to explicitly, by the way, okay. You don't need to explicitly specify the Docker hub, say Docker hub plus cub kini kini, because it automatically assumes someone is scribbling on my screen. That it automatically specifies the image. So when you put Postgres, it automatically knows that it's going to Docker hub to pull it. You understand? Because Docker hub is still connected to Docker. Container name is Postgres DB. The default port for Postgres is 5432. For MySQL, these are things that you have to put in your head. For MySQL, it's 3306. Like that. So when you're trying to create a Postgres container, you put the port as 5432. Then there's volume. Now, Docker volumes is used to store data. It's what they call stateful services and stateless services. Once you are trying to do, like try to get a container that you are going to store data in, you must create a volume. Because if this DB crashes now, if this database crashes now and you restart it, every data on that DB will erase and it will be like fresh container. So you don't want that. You want a scenario where there will be a volume. There has to be a volume. So this volume now, you will save it in this particular this thing, var.library.postgres data. This is what to save. To save this in your Docker installation in that server that's going to run this whole setup. To create this folder and save this volume. It's like saving like a flash drive. So for every data that is created on this DB, it's going to save it here. So if this database container goes down and comes back up, all your data will still remain because you just pick it from this setup that is here. Then environment. So this environment, Postgres user, password, and the DB name. It is this environment now that you go and put in your back end here. So when you are building the back end, you must ensure that it's the same thing. See now, Postgres server is the same thing here. So this is what you. So before you even put the before you even build the backend, ensure that you have the Postgres name, port, and everything set up already. They're already set up. So it's not to create a database with these credentials. So when the database is looking for when your backend is looking for a database with that credentials, it will find this one. The container name is Postgres DB. You can see. If you check your backend is Postgres DB. Look at it. Postgres server, Postgres DB. Port this, app this, change this name. So when it's going to look for Postgres DB, to go and look for that yourself is called Postgres DB. You do not try to enter it. Once it enters, you see that the username is app and the password is this. This is not even safe, by the way, just for practice. We're moving on. You can look for it and then enter and then either be pulling data from there or dumping data there. There are two ways pulling it. So that's when you know that your backend is connected to your DB. So these are the three main components. All these ones are just for other setup. Then under here, you set up the volume and the network. So it's from this volume and network now that we pull in the setup. So this one is Adminer. Adminer is like a dashboard for a database. You want to see a database UI. Adminer. It's not really compulsory. But this is just the basics that I'll even in your tax, this is the basics I will require from you. I've not yet set the tax up, but I know that people will do a Docker tax next. I'll skip Ansible. People will do a Docker tax next. So yeah, so this is basically how to set up a Docker compose. Now, once you set this up, what you do is you now do Docker compose up. So Docker compose up will automatically build this entire setup at the same time. Like I said, in this front end, the best practice is to put depends on back end, just like the way I put here. So that the first thing that will be built is DB. The first thing that will be built is DB because back end depends on DB. So the first thing, now once you put that Docker Compose up, you can check that depend and it will build DB first. Once that's built the DB first, it's not going to build back end because front end depends on back end. To build back end first, they now build front end. Once they have built front end, your application is live. You now ping the IP address and the front end will come up. Front end is connected to back end, and then back end is connected to what? DB. Shikina. That's how to deploy an application. Any question? Is there any question? Okay, well understood. I'm happy. I'm really, really happy. First time in history. Lord be praised. So, yeah. So that's just it in a nutshell. That's the whole concept around containerization. That's the whole concept around it. It's a very, very sweet stuff. Very, very sweet, especially when you're doing a large scale. When you're doing large scale. I once worked on a project where I wrote a particular code. But once I run the code, it automatically builds everything. It will build everything into it will build that code now, will build the code will build the front end, build the back end, build the database, build the monitoring. Now deploy it on a server. It will go to AWS and create a server. Now deploy all the setups in the server. Now get the IP address of the server and map it to a domain name. Now maps it to a domain name. Now maps it to a domain name. Once it maps it to a domain name, it will now also create a certificate for HTTPS so that this domain name will be secured on the same script at the same time. This thing will take you like 30 minutes once and it will run everything. So that's the level you need to get to, basically. So once any change is made to the server, to any of the code, it automatically build it and push it on the server. And then once you access the https://www.xthisthing.com, your front end shows for you. Don't worry. Then DevOps beginners. No wahala. So